Most people think a bulldozer is just a giant blade pushing dirt. That's not actually what's happening. Because the moment a bulldozer lowers that blade into the ground, a massive chain reaction begins inside the machine. Fuel explodes. Oil surges through steel arteries. Gears twist with forces strong enough to move buildings. And thousands of kilograms of earth suddenly become a problem of physics. What you're seeing from the outside is only the final result. Inside the bulldozer, an invisible system is fighting gravity, friction, heat, and raw resistance from the ground itself. And if even one part of that system fails, the machine stops instantly. But here's the strange part. From the outside, a bulldozer looks almost ridiculously simple. A big metal box, 2 tracks, a blade in the front. It feels like the most basic construction machine ever built. And yet, some bulldozers weigh more than 40 tons and can push materials that would stop trucks, cranes, and even tanks. So how does that actually work? Because a bulldozer isn't just pushing dirt. It's converting explosions into controlled force. And that story begins the moment the operator turns the key. Inside the machine, a diesel engine roars to life. Unlike gasoline engines in cars, diesel engines work differently. They don't rely on spark plugs to ignite fuel. Instead, they compress air so tightly that diesel fuel ignites instantly when injected. Each cylinder becomes a miniature explosion chamber. Fuel sprays in, pressure builds, and then, boom, combustion. That explosion pushes a piston downward. The piston spins a crankshaft. The crankshaft begins turning with enormous torque. Torque is simply twisting force. It's the kind of power you need when you want to move something extremely heavy. But here's the problem. That spinning force from the engine is far too aggressive to send directly to the tracks. If it did, the bulldozer would jerk violently forward and stall the moment the blade touched the ground. So engineers added something clever. A device called a torque converter. Think of it as a shock absorber for power. Instead of gears slamming into each other, the torque converter uses thick fluid spinning inside a sealed chamber. The engine spins one turbine. Fluid transfers that energy to another turbine. Power moves smoothly instead of violently. But that's only the beginning. Because bulldozers don't steer like normal vehicles. Cars turn their front wheels. Bulldozers don't even have wheels. Instead, they turn by doing something strange. They slow one track, while the other keeps moving. One side speeds up. The other slows down. And suddenly the entire machine pivots like a giant compass needle. But this introduces a huge engineering challenge. When one track slows and the other keeps moving, massive stresses build inside the drivetrain. Gears experience incredible strain. Chains pull against metal sprockets. And friction begins to rise. Engineers learned this the hard way. Early bulldozers often destroyed their own transmissions because the steering forces were simply too powerful. So modern bulldozers use specialized steering clutches and planetary gear systems. These systems distribute power carefully between both tracks. Instead of fighting the engine, the gears cooperate with it. But that still doesn't explain the most important part. The blade. Because when that blade drops into soil, the real battle begins. Dirt is surprisingly complicated. Loose sand behaves one way. Wet clay behaves another. Rocky soil behaves completely differently. Sometimes the bulldozer glides forward smoothly. Other times it feels like pushing against a wall. And this is where hydraulics enter the story. Hydraulics are the bulldozer's muscles. Inside the machine, a hydraulic pump forces thick oil through steel pipes at extremely high pressure. Sometimes more than 3,000 psi. That pressurized fluid enters hydraulic cylinders connected to the blade arms. Inside each cylinder is a piston. When oil pushes against the piston, it moves outward. And suddenly the blade lifts, tilts, angles, or slams into the ground with enormous force. The fascinating part is how hydraulics multiply strength. A small movement inside the pump can generate thousands of kilograms of force at the blade. It's similar to using a long lever, but instead of metal bars, Hydraulics use liquid pressure. But here's where things get strange. Hydraulic systems create enormous heat. As fluid squeezes through valves and tubes, friction builds. If the oil gets too hot, it becomes thinner. And when hydraulic oil thins out, pressure drops. That means the bulldozer loses strength. The blade becomes sluggish. And the entire machine starts struggling. So bulldozers include dedicated cooling systems just to keep hydraulic fluid at the correct temperature. But even that isn't the biggest challenge. The real problem is traction. Because pushing dirt isn't just about strength. It's about grip. If the bulldozer can't grip the ground, all that engine power becomes useless. That's why bulldozers don't use wheels. They use tracks. Tracks distribute the machine's massive weight across a large surface area. Imagine walking on snow. With regular shoes, you sink. But with snowshoes, your weight spreads out. You stay on top. Bulldozer tracks work exactly the same way. Each metal plate spreads the machine's weight across the ground. That allows a 40-ton bulldozer to crawl across mud, sand, or loose soil without sinking. But tracks do something else. They bite into the ground. Every plate digs slightly into the surface, which means the harder the bulldozer pushes, the more grip it gets. But that advantage comes with a cost. Friction. Thousands of metal components grind against each other inside the track system. Rollers, pins, bushings, sprockets. Each connection moves every time the bulldozer advances. Without lubrication, the entire system would destroy itself quickly. So bulldozers constantly pump grease into these joints. But even with lubrication, track systems wear out faster than almost anything else on the machine. Yet even with powerful hydraulics and massive tracks, another problem appears. Balance. When a bulldozer pushes a large pile of dirt, the weight shifts forward dramatically. Imagine leaning forward while holding something heavy. Your body wants to tip. The bulldozer experiences the same physics. Engineers solved this by placing the heaviest components toward the back. The engine, radiator, fuel tank. These act like counterweights balancing the blade. But even this solution created new challenges. Early bulldozers sometimes lifted their front blades when pushing extremely heavy material. The rear weight pushed down so hard that the front lost grip. So engineers carefully tuned the machine's center of gravity. Not too far forward, not too far back. A perfect mechanical balance. But the environment bulldozers work in creates another hidden problem. Dust. Construction sites are filled with fine particles. These tiny grains can destroy engines. If dust enters the cylinders, it behaves like sandpaper inside the engine. Metal surfaces grind away. Engines fail. So bulldozers include powerful filtration systems. Air passes through multiple filters before entering the engine. These filters trap microscopic particles. Without them, the engine could be destroyed in days. And even with perfect filtration, bulldozers face another enemy: heat. Massive diesel engines produce enormous thermal energy. If cooling systems fail, temperatures rise quickly. Metal expands. Oil breaks down. Engines seize. So bulldozers rely on large radiators and powerful cooling fans to keep temperatures under control. But here's where things take another unexpected turn. Modern bulldozers are no longer purely mechanical. Inside many machines today, computers constantly monitor the machine's performance. Sensors measure blade position. GPS systems track the bulldozer's location within centimeters. Software adjusts hydraulic pressure automatically to maintain precise grading angles. In some cases, bulldozers can even follow digital terrain maps. The operator guides the machine, but computers help ensure perfect accuracy. Entire landscapes can now be shaped with astonishing precision. And yet, despite all this advanced technology, the basic bulldozer design hasn't changed much in nearly 100 years. Tracks, blade, engine, hydraulics. The same core idea. Because engineers discovered something rare. A machine design that was already incredibly efficient. But perhaps the most fascinating part is what a bulldozer actually represents. When you see one slowly pushing soil across a construction site, it may look ordinary, just another heavy machine doing dirty work. But inside that machine, physics is being harnessed in one of the most powerful ways humans have ever engineered. Explosions inside metal cylinders become torque. Torque becomes motion. Motion becomes hydraulic pressure. Pressure becomes force. And that force reshapes the surface of the planet. Roads begin this way. Airports begin this way. Cities begin this way. Entire landscapes move because a machine like this exists. So the next time you see a bulldozer pushing a mountain of dirt across a construction site, look again, because inside that steel frame is a carefully balanced system of explosions, pressure, and engineering precision. Thousands of parts working together so one simple blade can do something extraordinary. Move the earth itself. And once you understand what's really happening inside, you'll never look at a bulldozer the same way again.